So welcome to the community call for May the 31st. It's great to have you here. Today we have a packed agenda. My name is Mark Fussell and I'm a maintainer and an STC member of the Dapr community. And on our call today, we have a pretty packed agenda. We're going to start off with Hareesh talking about using Dapr with his company he works for called Openplay and building Dapr into games. Then we're going to move over to Eddie, who's going to spend some time walking through a proposal on how we could support HTTP middleware in our service-to-service invocation. Xavier will give a little update around what we're doing with Node and NPM packages, just in terms of how we're changing where they get access from. And then we'll finish up with Hal, who will talk about the built-in retries that we're putting as part of resiliency policies, which is an upcoming feature capability coming in the 1.8 release. And it builds upon sort of some of the resiliency discussions we've had in our previous calls. If there's a bit of time left over, we'll have an open discussion, but feel free to post questions as we go along and enjoy the agenda. So with that, I'm going to switch over and let Hareesh take over. So I'm going to stop sharing. Hareesh, please share.
Hi, I'm going to share my screen.
Yeah, we can see it.
Yeah. Today we are going to discuss about the Dapr and accounts integration. And I would like to introduce myself first. And I am Hareesh Kumar. I'm a hands-on software architect working at Openplay Technologies, and our company develop games. And so I worked on 13-card rummy game, and I've been working on this game since a decade, and I have seen this game from the age of bare metal servers to now the Kubernetes deployments. And with that, I am going to start with the game background. So this is a 13-card rummy game, and it's a simple game, and we offer this with the brand name classicrummy.com, and we offer this to the entire Indian population. And on an average per day, 20,000 tables run, and there are times where we require the scaling up and scaling down of the number of tables that we require. And this is a very simple game. I hope you know about this one. And the current production setup I'm going to show you. So this is our current production setup, and we just deploy our Docker containers on EC2, and the user comes after the URL gets routed through the ALB, and after that the request comes onto the application server, and application server runs with the help of the databases that we deploy on EC2. And in the recent changes, we have migrated this architecture to the Kubernetes architecture, and right now we make use of the Amazon EKS, and we have the request coming through ALB, and after that we have the service taking up that request, and we have the pods running, and the pod utilizes the Dapr sidecar to communicate between the applications. So on our private subnet, so we have our node, and on the node we have the pods, and Dapr sidecars communicate between the applications. So we have picked up Dapr 4 months ago, and this is to help us with the cloud native implementation of our game. And we have developed our microservices, and our microservices utilize Dapr for the inter-process communication, and we also use PubSub feature of Dapr that we use for the async communication between the applications. And I'm also going to share some of the information how it's running in our production. This is the overview of our Dapr system, and we have our Dapr pods running, and these are some of the metrics in our production environment. And we can also see how better the inter-process communication is happening with the Dapr. So here we go. On an average, the time taken for the inter-process communication is less than a second, and it's between milliseconds to up to second, and this is up almost 99.9% of the traffic is completing under a second, and very rarely the other requests are taking time. So basically, we have picked up Dapr for its ability to use it as a sidecar to our game server application, and to help us with the inter-process communication and state store, and also the secret store, and also the PubSub, and the bunch of features that the Dapr is offering us. And thank you for the Dapr. And so now we, as a second phase of our requirement, so we have picked up Agons, and how Agons is helping us. So Agons is built on top of Kubernetes, and it's an open source platform, and it's a Google offering, and it helps us deploy hosting and scaling, orchestrating of the game servers. And this is where we have we started using this Agons, and currently we are prototyping it, and in future we want to go live and want to use Agons in the production. This helps us handle the large scale multiplayer games. As a game developer, so the core requirement would be to cater to the increasing loads. So during day, there are different traffic patterns wherein players will be very active during evening sessions, and players will not be that much active in the early morning sessions. So the load that comes to us is different in a day and different in a week, and it is different at different times. And it is also possible to get sudden surge in the traffic. So this is where we require the auto scaling and scaling down, which saves us the infra cost and help us develop a very well written cloud native application. And since we already have Dapr in our production, and it's helping us already with the inter-process communication, and we want to use Agons in the future for the scaling part of our game application. So I give it a try of integrating Dapr with Agons, And the benefits would be like Agons help us with the auto scaling and management of the game server applications using pods. And Dapr helps us with the PubSub and async communication, and also the direct invoke and interprocess communication between our microservices, the game and also the platform services. So for the integration, I tried first to annotate my game server part. This is the standard way that we do for our like applications, and that's how we did earlier for going live with Dapr. So I'll quickly open up the YML file and show you the configuration. So I annotated.
Hareesh, we're still seeing the slide. No, we're not seeing.
I'm changing this. I'm sorry for that. I hope you are able to see the YML file. Right?
Yeah.
Thank you. So we have annotated our part with the Dapr annotations, and we have picked up our sidecar image and enabled Dapr and give our app ID and port, and we're given the configuration. And with this, we will end up with an error in the sidecar injector. So I'll show you the error. So since we have the allowed control service accounts declared in our injector.co file, so these are the controller service accounts which are allowed to prompt for a sidecar being injected in the pod. And because Agons comes up with its own set of service accounts, so this sidecar will not be injected because it is not in the allowed list.
Yeah. Hareesh, there is something that you might be able to do to allow for the service account for Agons to be able to inject sidecars. I actually helped another user with something similar. So I'll put it on the GitHub issue, and if okay with you, in the next few days, if you can just try out the steps I'm going to outline and tell me if this works for you, that'll be really great. Because I think there is a way we can actually allow for this to work without adding, the controller into this list.
Yeah, that would be a very great feature to have, Aaron, and it helps us different kinds of technologies to integrate with Dapr.
Yeah, so what I'm saying is there might not necessarily be a feature needed here. There's something you can do that'll make it work today, because there's two different ways that the injector basically checks whether or not a service account is authorized to inject a sidecar. One is by looking at the controller service accounts in the list here, but then there's like a user group that you can also create a cluster binding for. So I'm going to tell you exactly what you need to run. I'm going to put down the issue, and we'll see if that solves it. If it doesn't, then we've also been talking in the past about putting in a feature that's a config map that will allow users to specify which service accounts in which namespace are allowed to inject sidecars. And so it'll be configurable so that we won't have to hard code them like this. So let's start out with a different way that might work today. And if that doesn't work, we'll look into adding this feature. Does that sound good?
Thank you, Aaron. Actually, it sounds great, and it would be like opening up the possibility of integrating Dapr with different technologies. And
Yeah,
today,
yes,
tomorrow, it will be something. Yeah, that will be great, and look forward for this information. So after I hit this issue of the service account not in the list, so I have tried in a different way. So I'm going to show that also. So Icons accepts multiple containers to be created, and so I have my game server container mentioned here, and Icons also runs similar to Dapr in terms of running as a sidecar. So it runs as a sidecar to my game server application, and it listens to the game server lifecycle events. So to name a few, it will be like the game server will mention the update the sidecar saying that it's ready and it can be allocated. And once it allocated, it also says that it got allocated, so that the scaling up and scaling down does not delete this part. So the total life cycle of the game server will be like a game instance will be managed by the Agon sidecar. And this is the container for the game. And second one would be this is one container. And second one would be the Dapr sidecar container. I can create one more container and I can mention my Dapr image, and I can also set the environment variables which are required by the Sentry service. So I just need to set these 4 environment variables for the Dapr sidecar to use. And I can also mention the control plane address and placement host address and Sentry address. And I can also mention the Kubernetes mode, and I can also give the app port and other required information for the Dapr to run.
Yeah, so
And
you're basically doing a manual injection.
Yeah, manual injection we can try, and with that, my sidecar spinned up, and it's up and running alongside my game server application and also Icon sidecar. I'm going to show you that. So here we can see 3 containers are running here. So game server has 3, and so one is my game server application, and second is the Icon sidecar, and third is the Dapr sidecar. So this is Dapr sidecar, and it has these arguments taken up, and state is running, and it's ready to.
This is great stuff. So, where do you? But I think you're not going to go down this path because your own will have another solution for you. Yes.
I could not hear you.
I was just saying that this is another path that you explored, but this doesn't necessarily have to be the one that we implement because we can find a better solution with Dapr. Yes.
Yeah, if to quote the greatest Batman movie of all time, The Dark Knight, this is the solution that you want or need, but it's not the solution that you deserve. Yeah, definitely the solution you need, but not the one you deserve. You deserve better than this, and better means Dapr being able to work with whatever service accounts are out there to inject the sidecar. So again, I'll work with you offline to get this working.
Sure.
Yeah.
Look forward.
Okay.
This is just a try, and architecturally this may not be the correct solution to work with, that I understood.
Yeah, I have a different question. I see that you're using your own Dapr version. Can you explain why that is? Like your own Dapr image?
Yeah. So we have when we were integrating the Dapr first time, that time my game server listens to the sig term signal, and it gracefully shuts down in an hour or 2. So it waits for the last player to finish his game and then gracefully shuts down. And the time the Dapr is shutting down within 5 seconds after receiving the sig term. And for that, I have raised a request, and it made configurable. So now we can give the graceful shutdown period, and within that time, the Dapr sidecar also waits. So at that time, we have changed Dapr code to handle the graceful shutdown and wait till the game server completes. So that's why we are using our custom build.
Okay. Okay. Got it.
Okay, Hareesh, your microphone has just gone down, so you might just want to turn it up again if you can.
Yeah.
All right.
Is it fine?
That's good now. Yes. All right.
Yeah.
Is there any questions that people would like to ask? And how would you like to summarize this? It sounds like you're doing an amazing job bringing together the Agons community and the Dapr community so that those two can work together and you can run both as sidecars and use them in games development. Would anyone love to ask any questions?
Before this question and answer session, I just want to conclude this particular way of integrating by saying that if we integrate in this way, we will end up with a error again at the while invoking other service directly. So if we invoke the other service, we will get this error direct invoke, fail to invoke the other application, fail to invoke target after 3 retries. The gRPC call from Dapr sidecar to Dapr sidecar is failing in this approach. I just want to mention that because we are manually injecting the Dapr sidecar. It's up and running, but when we actually try the direct invoke to call the other applications, we will get this gRPC call failing error.
Yeah, I mean, yeah, again, this method of injection is not recommended, but if you want to see why that's failing, did you try running with debug logs and seeing what the actual error is in the Dapr container?
I tried to go to this pod and call my service, some other microservice by calling my Dapr localhost. I did that, but the call is simply failing at the gRPC level. So yeah, I'm able to call my sidecar.
So what I'm saying is, if you go to the arguments that you give the Dapr container in your YAML, you can add a log level there and specify that it's debug, and then it'll show you more detailed logs.
Yeah, I have did that. So I set up the log level to debug.
Oh, okay. All right.
But simply it is only printing out this particular message saying that the direct invoke failed after 3 retries. There's no further logs, and I set the debug, the log level to debug.
Right. Yeah. It's going to be a bit of a pain trying to figure out what went wrong here with the manual injection, just because there's so many things, both the, oh, wait, I think I might know what that is. Did you create the Dapr service for your sidecars? Did you create? Sorry?
I have my Dapr control plane running.
Can you do kubectl get service? Can you get SVC? Yeah. No. So can you do kubectl get SVC?
This one, sidecar injector.
No, kubectl. A type. I'm going to put it in chat. Hold on. We're having a live debug session now, and we have
the amount of time debugging this is very small because we've got other agenda items. So
yeah, we should move on. But Dapr also creates services for your applications, so you should make sure that these services are available. And yeah, I think we can move on now.
Yeah. With this, I summarize this one saying that the Dapr and Agons integration would be helpful for game developers around there, and I am looking forward to get help from Yarun and fix this issue so that the Agons work with Dapr, and it helps us other tools and other things to get integrated with Dapr for future. And with that, I open up for the Q&A session, and I'll be happy to answer any questions.
So this is excellent stuff. Do you know any other companies who are using Agons and Dapr together?
Sorry, I didn't get you.
Do you know of any other companies or other who are going to be using Agons and Dapr together that you're working with, or is it just yourself?
No, as of now, like I have like explored the internet for some help to integrate these two, but I did not get any particular resources to do this one. And I'm very sure that like game developers must be using some kind of service mesh implementations, maybe Linkerd, maybe like Istio or something else. So I guess somebody may be using it, trying to integrate it to.
All right. Okay. Well, thank you for that. That was a fantastic overview, and
Thank you.
we'll get you fixed up. So we'll make these two communities come together. All right.
Thank you all.
Right. So with that, let's move on. Eddie, you're up next. So if you can share your screen.
Will do. Just one sec. Share screen. All right, everybody see my screen?
Yes.
Perfect. First of all, thank you so much for giving me the opportunity to speak today. Hopefully, this is a fun topic we can discuss, and hopefully it goes my way. But what I'd like to propose is supporting some of the HTTP middleware configuration that already exists in Dapr when we make service-to-service invocations. So just as a quick refresher, HTTP middleware is a way for us to add additional logic that's separated from our application in the Dapr execution pipeline. And it's very specific to HTTP at this point. So there's a lot of really useful middleware components out there. We use quite a few of these, but some of the examples are rate limiting. And so this allows us to kind of add a way to stop overloads across a particular service, OAuth 2, either grant or client credentials, bearer validation, and OPA, Open Policy Agent execution in the runtime. So these are really nice because with rate limiting, we can create a bulkhead on top of our service for some of these legacy services that may not be capable of handling it. And the idea is maybe it's just this one service. Maybe we can fail quickly and go to another service in our different number of pods that have been deployed. And a lot of what we use Dapr for is augmenting our legacy services. So we found a lot of benefit from adding Dapr sidecar to existing pods that either don't have rate limiting or in this particular, the next two cases, they don't have a way to standardize OAuth implementations and trust a new identity provider. Now, whether we're wanting to go to an Auth0, an Okta, Google, these things usually require coordination across many teams, or we can do this declaratively in a Dapr config and publish it out to a bunch of teams. The bearer one is also very useful to us because it allows us to verify, cryptographically verify that's JWT. And we can point it to the JWKS endpoints. It'll automatically verify that the bearer token is valid, that the expiration hasn't elapsed. Very simple. The developers don't have to modify any piece of code. And then finally, this is the one we're probably using the most, is our Open Policy Agent. And this is truly decoupling our authorization from our code. So we can now do this in a simple YAML file that has a Rego script in it, and we can publish rules onto what you can and cannot do based on the incoming request. We can even go out and call our authorization server. We're using a flavor of Zanzibar, which is a Google project, to pass in that JWT, get really fine-grained access control, and reject it all through the Dapr sidecar without having to change the code whatsoever. So it's very, very beneficial for us. We also use the Dapr sidecar direct service-to-service invocation in a lot of places for similar reasons. Of course, the first is adding mutual TLS. That's something that overnight we can elevate the security of all of our internal calls without having to do much, really. You add the sidecar, you add the value and it's good to go. The open tracing header injections have been a lifesaver. They've exposed our ability to see who's calling what in the previous dark area of our services. It's been really beneficial. And anywhere that we've had a host name in a config for a service-to-service invocation, we've simply replaced it with the call to the local sidecar using that previous host name as the app ID. So we've been able to take things like an instance of our Spotify Backstage project and add Dapr to it to add authorization and to add tracing. We've been able to take our Docker registry, and through adding our Docker sidecar to it, we can now pub sub all the Docker events to wherever we want. So it's really been probably, I'd say, the lion's share of our implementation has been using these with our existing systems, even third-party systems, through a declarative GitOps manner. Now, the gap that we found is if you have the HTTP middleware and an upstream service is using Dapr to call it, that service-to-service invocation bypasses the HTTP middleware configuration. Now, whether that's one configuration or multiple, it'll bypass and go through. There's a very popular blog post about how to use ingress to call backend service-to-service invocation by creating your ingress controller as a Dapr app. And unfortunately, that will entirely bypass your HTTP middleware. And so this is kind of where that sparked this issue and became an issue for us what we were trying to solve. So the proposal is to respect the middleware binding, regardless of the call type. So service-to-service invocation is primarily done over gRPC. So rather than calling it HTTP middleware, I guess it could be middleware binding, and allowing us to propagate any additional information based on that call type. And this would be very beneficial for OPA. Today, you get a lot of the HTTP headers, but maybe you get some gRPC specific information, or at least a value that says whether it came from one or the other. And that'll allow us to add additional Rego script and additional fine-grained access control in those scripts that we have. So that's it in a nutshell. Let's open it up, I guess, to discussion.
First of all, it's really great to see the way you're using Dapr. That's really awesome. Also, I think it's really great to see usage for HTTP middleware. I personally wasn't aware of too many use cases for that, so it's also really great to see how you're using that. On the issue specifically, I think you mentioned having the middleware also apply to the channel that Dapr is creating when invoking the app, right?
Mm-hmm.
So
That's
is that
correct.
what you mean here by respecting the middleware binding regardless of the call type? Because currently the middleware is invoked when the app is calling the Dapr API for HTTP, right?
Yes, it's only over HTTP. So if you call it over gRPC port, it will not go through the bindings.
Okay, so there's two things I want to discuss. First, I completely agree that it should also apply to gRPC. If you go into Dapr and into pull requests, you'll actually see there's a draft PR to enable gRPC middleware already. It's been opened a while back by a contributor named Johnny Collins, and it's kind of been abandoned since then, but there's a PR out, and he at least proved that, you know, this is possible and there's a good design there. So we might just take that PR and give it attention again and bring that in, because, you know, I definitely think if Dapr supports HTTP and gRPC, whatever protocol it supports, if it supports thing like middleware, then it should support it for all given protocols. So personally, I fully agree with you there. The other thing is, do we enable middleware not just when Dapr is called, but when your application is called? And that's something different that I wanted to discuss with you.
Could you say a little bit more about that? What do you mean on my application?
Yeah, so today, when your app calls Dapr, the middleware will basically kick in. So the middleware is applied to the Dapr gRPC, or sorry, the Dapr HTTP server. But yes, you can also have middleware that's enabled when Dapr invokes your application based on an event, right? So for example, think about the rate limiting middleware. You could use that, for example, to rate limit, not the Dapr sidecar, but how your application is being called from Dapr. That's just one example. And I've seen other users ask for this too. That's, I wasn't sure if it was you who asked for that, but that's something different that I think we need to make.
If you're referring to events, I think that'd be very, very useful, especially with the control plane that Dapr has, being able to summate or aggregate those rate limit calls. Today, this middleware is only specific to that instance. And so we sometimes have long running calls that even though the Kubernetes service does not route correctly, or that the Dapr service will still route to it, the rate limit can fail it. And the desire would be for the service to service invocation to very quickly try another instance. And that way we can benefit from both. But if you're talking about events, I think that'd be even better, because we can now have an implementation rate limit be across the board versus just an individual instance.
Yeah, I agree with you. This is also a useful feature. It wasn't specifically what I was talking about here, but yeah, having like a distributed rate limiter is really interesting. We did start implementing things like resiliency policies, but as you've mentioned, they're per sidecar. But there is an intention to look at these for distributed counting, so to speak. I think Arthur has his hand up for quite a while now.
It's okay. Thanks, Yaron. Just one additional comment here. Yeah, I do see a huge potential in this proposal. My only concern here will be between HTTP and gRPC. So if we want support gRPC, I think it should be with components specific tailored towards that. What do I mean by that? I mean that a component should not have one code that should handle both HTTP and gRPC. I think each code for middleware should be protocol specific. We had tried that before to make like service invocation work code be unique for both HTTP and gRPC, and we had like a huge mess with that. We tried to stop that. Yaron probably remembers that point in time. So I think that middleware should be HTTP middleware, and gRPC middleware should be just separate type of components.
Yeah, I generally agree. So what do you think, for example, about something like a rate limiter middleware that receives events that are not tied to any given protocol? That's like an example of a shared business logic that can be applied across multiple ones.
Well, it depends. And the reason why I say it depends is because, for example, in HTTP, you can have different paths and different patterns, even wildcard on what case that rate limit applies, while in gRPC will be like the method name, So there are some similarities there. But even if we do that, the component can be applicable to both, but we need to implement two different interfaces.
Yes, I think that makes sense.
If I could offer a counter argument to that, when I build a service that's HTTP, I only know about HTTP. Even though the service-to-service invocation might come over gRPC, with my developer hat on, I'm thinking of HTTP. In my particular case, my Rego script and my binding is about my HTTP endpoints, their verbs, and their paths. Whether it came through gRPC or not, I don't know. And so if I have to implement two interfaces, it might get confusing to people, it might reduce, I think, the adoption. Versus if I'm exposing an HTTP service, I should only care about my HTTP bindings, even if it came from one or the other. Does that make sense?
I agree with that. What I'm trying to say is, if a component is applicable only to HTTP, yes, you only implement one interface. But if you also want to support gRPC, there has to be a separate interface for gRPC.
Yes, I agree, but service to service is always going to be gRPC, even if it's then turning around and calling my HTTP endpoint. Is that correct?
Yes, I'm referring to the point where the Dapr sidecar is invoking the application. So by the time the sidecar invokes the application, then has to be it has to pick a protocol, HTTP or gRPC, right?
Yes,
So at that point,
I
that
think so.
because before in the past we had a situation where a client, HTTP client, could invoke a gRPC service via Dapr, and vice versa, and that did not play well. So if a client is making HTTP call to a HTTP service through Dapr, the receiving end has to be HTTP as well, and same thing for gRPC. So we don't do the translation in Dapr anymore between gRPC and HTTP. And I think in this case, we should remember and apply the same concept here, where if your component is a middleware for HTTP, you have HTTP interface. If your component is a component for gRPC, you have a gRPC interface. And if your component is for both, you implement both.
I think that's fair. I think that's fair as long as, you know, the implementation of the actual code is what I would have to build the middleware for. I think that makes it easier for developers to kind of grasp the bridge, and it doesn't matter whether it's coming from sidecar or direct invocation through the sidecar. And if it is a gRPC service I'm building, then you build a gRPC middleware. If it's HTTP, you build HTTP middleware. I think that makes sense. It's easier to grasp as well.
Okay, thank you. I just made this comment on the issue, but apart from that, looks good to me.
Yep.
Okay, this is so how do we think of progress on this? So I think, do you think you have an answer, Eddie? Are you and you okay with the answer on this and how we can progress and have the conversation on the rest of the issue?
I think so, yes. And I think the discussion on the issue has been great. So I appreciate everybody's jumping onto it. And I think we have a path forward.
All right.
Yep.
Fantastic. All right.
Thank you.
Thank you. This is
Thank
good.
you very much.
Yeah, and I love the use cases that you put together. They were very compelling for the middleware. We don't necessarily.
Yeah, we found a lot of value. It's been great, and I want to thank all the contributors. This has been phenomenal. It really solves a lot of problems, and the more we use it, the more benefits we're getting out of it. So thank you so much for all your time and efforts.
Thank you so much. That's great to hear.
Okay, fantastic. Right, let's see if we can close on our last two agenda items. Amelia is just going to give a short update around changes to our NPM client package. Amelia?
Yep. Thank you so much, Mark. I hope you all can hear me.
Yes, we can.
Okay, perfect. So yeah, we have an important announcement from JSSDK in this community call. Since the release 2.3.0, JSSDK will be moving to a new NPM package, which is Dapr. So we also have an issue to track or to deprecate the existing Dapr-client NPM package. So the plan goes something like this. The packages will continue to receive the same updates till 1st of November 2022. And after this time period, right, Dapr-client package will continue to be maintained without updates till 1st of April 2023. So once we have confidence that we don't have enough downloads and it's completely or it's almost inactive, the package will be archived. So yeah, this is an important update from JSSDK, and we'll be looking forward to getting support from the community on this.
Good.
Yep, that's the update I have.
Great. And is there an issue tracking this that people could just kind of find out those dates that you talked about?
Yes, we have this issue 259 under JSSDK.
Okay, perfect. That's where I can find out more.
Yeah. Thank you so much.
Okay, thank you. All right, and then last item on our agenda is that we have Hal. Hal, are you there? And
yes, I am.
All right, I'll let you display, take over, and screen share.
All right. All right. Oh, is that the right screen? Do people see the PowerPoint?
I can see your PowerPoint, yes.
Awesome. For some reason, the Zoom is showing up on a different screen for me, but as long as it's showing the PowerPoint, that's what we need. Go. All right. So I just want to take a quick moment to talk about the built-in retries in Dapr. and how we're going to move them over to resiliency. Because right now, resiliency released in 1.7. There are some cases where your resiliency policy might overlap with some of Dapr's existing retries, which can cause a case of, retries kind of really building up on each other. And that might not be the desired behavior. So we wanted to provide a way to kind of transition from those built-ins to resiliency without the risk of just, having all the all the built-in retries removed immediately, because you might not be ready, for a one-shot transition when you're moving to resiliency. You want to make sure you still had some of that backup. So first, where does Dapr already retry? It actually has a fair number of places where it already does do retries. The biggest ones that I think are kind of really important here are things in like the cross sidecar communications, such as service invocation and remote actor invocation. It also will do some things in the initialization procedures, like determining subscriptions. That's calling into your app, seeing what you're subscribed to. And there are a few other places there where it can do some other things. And then there's also just a fair amount of component operations that are already retried inside of Dapr internally, both from the actual component side of the world, as well as from the Dapr sidecar part of the world. Areas like pub sub and bindings, those can re-deliver your messages to your app based on the technology that you're using. But things like actor state store operations, where you're storing reminders or iterating over anything of that sort involving actors, the sidecar itself is actually doing some retries after monitoring how the operation's gone. So there's a fair amount of existing retries in here, and we won't be targeting all of these in this built-in resiliency, but we'll be targeting some of them, which I'll get into in a second. So first, just a quick review of resiliency policies again. They are a YAML or a CRD. You can set your policies, which are things like timeouts, retries, and circuit breakers. Timeouts, pretty self-explanatory. It'll cancel your request. Retries, pretty self-explanatory. It'll retry. And then circuit breakers, a little bit more complicated, but essentially they are a switch to allow you to stop traffic to certain things based on certain scenarios. In the case of this policy, that consecutive failures is greater than 1. And then you can also have a series of targets. This just lists some components here, but you can also target apps and actors as well. Apps by the app name and actors by the actor type. So quick refresher on resiliency there. So the goal here was to provide an easy transition with between the existing retries and the new policies. The plan here is to be able to, instead of using kind of ad hoc retry code throughout all of Dapr, to move it into the actual resiliency framework without again leaving anyone hanging. So essentially what we're trying to do for 1.8 is, when you have a resiliency policy defined, we're going to start allowing the Dapr sidecars to detect when you have a resiliency policy, and then only use resiliency in that case. If you don't have anything defined for that application, it'll instead switch over to using a built-in resiliency policy that's now being defined within Dapr, not via configuration, but actually an in-memory structure that will be loaded in every Dapr sidecar. And then if you don't have resiliency enabled at all, as it is a preview feature, it'll still use that old code path, so that way we have a multi-step path here, existing retries, switching over to the existing retries, but in a built-in resiliency policy, and then finally switching to the actual defined resiliency policy. The side benefit of this is that it also allows you to now start actually specifying your built-in resiliency policies yourself and overriding those policies. So if you're finding, in the case of a service-to-service invocation, you're seeing a lot of cases where the sidecar communication portion is failing, which is where the Dapr built-in retries exist. You could override that yourself and say, hey, I actually want more retries than Dapr is currently providing for me. That number, by the way, is 3. It's how many times Dapr retries internally. But you can start overriding these things, and that's why we have a few supported areas. We have the Dapr built-in service retries, Dapr built-in actor retries, and Dapr built-in initialization retries. So the few areas where we actually will have these things here. And then as a quick example of how this all works. So I have, my setup. My setup has a test app 1 and a test app 2. If resiliency is disabled, this uses the existing built-in retries, no change, everything is fine. If you do enable resiliency, that's when things start using the new resiliency policies. And you can see here, I have a resiliency configuration that I've made, and it actually defines the built-in service retries, because I've noticed in mine, I want a slightly longer back off and I want to do 5 retries. So I can specify that in my resiliency policy and have it override that. But at the same time, I can also specify a dedicated retry policy and then reference it in the application. So test app 1 uses that defined resiliency policy, and test app 2 will again use the built-in retry, but now with the resiliency override. So that's really what I wanted to talk about. I know I went pretty quick because we were tight on time there, but does anyone have questions on that?
So Hal, if I understand correctly, then for the built-in retries, there will be some sort of names that are kind of predefined that you can use to override, right?
Yeah, that's what these guys are: the Dapr built-in service retries, Dapr built-in actor retries, and Dapr built-in initialization retries.
And the Dapr built-in service retries apply to all the building block, the APIs. So, for example, state management, service invocation, secrets. Is that the way it works?
So that's right now, the built-in service retries, that applies to the actual service retry functionality. Actually, this is, I guess, an important part that I kind of skimmed over. But Dapr's existing built-in retries, they're for some pretty specific scenarios, which is what I was mentioning here. It's actually in just the cross-sidecar communication. So the built-in Dapr retries are looking at specifically if your sidecar is returning a unavailable or unauthenticated error. So this essentially cases, like your sidecar is not up yet, or the other sidecar is not up yet, or you're having like maybe you had a cert rotation and the certs aren't synchronized yet. So it's a pretty specific scenario, and that's what the built-in retries cover, which is the kind of the path that we're trying to provide out of this, where we don't want to take away that functionality, because your basic network level retries are fairly important in a service to service invocation, because networks can be flaky. And what we wanted to do was provide a way for you to enable resiliency and feel confident that resiliency was working and functioning well, and then make sure you didn't lose any retries while you were still getting up to date with your policy, making sure you weren't missing anything. And then once you had that policy and you have like your actual applications defined, switching over to just that. And that's when you actually get the full, we actually retry and everything. So here's when you actually define the policy. But until that point, we're mimicking Dapr's existing behavior. So that way you don't have any weird changes of behavior until you are ready for it, essentially.
Okay. So I guess my question is, do I get out of the box built-in retries for like state management, for example, or will that always require me to provide a resiliency policy myself?
So right now, that'll require a resiliency policy, except for some specific areas where Dapr already retries.
Yes.
One thing that this code does kind of enable is the idea of the more generic policies, where maybe that's what you want, is you want to be able to say, hey, for my state stores, I want like just 3 retries across all state stores. And that's something that this code's starting to be able to enable. So I was actually planning on opening an issue before the end of the milestone. I know we're getting kind of close. Seeing if there's a desire for that, for like these more quote generic policies, and seeing if that's something I couldn't fit into 1.8 as well.
Makes sense. So this is coming in 1.8, yes?
Yes, this here is in 1.8, and then we'll see what else we can kind of get in before the milestone closes.
Okay. All right.
Cool.
This is cool. Any other questions on that before we do? Well, we've had a lot of feedback about resiliency on the whole. People have had some great experiences with it. They've been really liking the ability to provide those retries, those timeouts, and the circuit breakers. So, we're going to work through this. We're not going to be having, just one more question, it's still going to be a preview feature in 1.8, yes? The resiliency policies?
Sorry, can you repeat that question?
It's still going to be a preview feature in 1.8.
To my knowledge, yes. I don't believe we've made it.
Yeah, it's still going to be a preview.
Okay. All right. So with that, unless there's any last questions that people want to have, I think we're out of time. We will have the next community call in 2 weeks' time, which will be in the Asia time zone. I want to thank everyone for presenting today. It's been a great, diverse set of topics, and we'll see you next time. Thank you.
Thank you. Bye-bye.